When you look up at the night sky, it's incredibly easy to picture the universe as a giant empty room. We intuitively imagine a massive dark void where planets, stars, and galaxies are simply placed inside, like furniture scattered across an empty floor. But that premise is entirely false. What we casually call a vacuum has a hidden, active, and dense underlying structure. To see how we got this so wrong, we have to rewind to 1887. Back then, scientists were hunting for something they called the ether. They assumed the universe was filled with a physical, gelatin-like substance, a mechanical medium with invisible gears that allowed light to travel from star to star. The famous Michelson-Morley experiment was designed to find exactly that, but it failed. They found absolutely no trace of this mechanical ether, and from that single null result, humanity falsely concluded that space must be totally empty. The experiment's failure didn't actually prove the void was empty. It only proved that our rigid, mechanical assumptions about how the universe operates were completely wrong. Think about trying to measure a magnetic field with a glass thermometer. The thermometer will read 0. That doesn't mean magnetism doesn't exist. It means you were using the wrong tool. In the late 19th century, we simply lacked the scientific language to describe non-mechanical structures. But the vocabulary evolved quickly. By 1905, Einstein's theory of relativity stepped in and completely removed the need for a mechanical frame of reference to explain the cosmos. Move forward to the 1920s, and the pioneers of quantum mechanics introduced a microscopic world driven by statistical probabilities and wave functions, replacing solid gears and rigid parts. Then, in 1948, Claude Shannon published The Mathematical Foundation for Information Theory, defining how structure and logic can exist without a physical, material medium. Shannon provided the mathematical language required to describe a universe built entirely on information, rather than gears, pulleys, and cosmic gelatin. The mathematical ether represents an informational substrate, a field of phase relationships and data that permeates everything. Modern physics already accepts that the vacuum is alive with complex structure. We see it constantly in phenomena like quantum fluctuations popping in and out of existence, and the invisible web of the Higgs field giving particles their mass. Physicist Melvin Vopson explores this idea further by proposing that information has physical mass. He asks whether the movement of matter through this substrate is actually governed by a set of computational rules. This introduces the concept of computational gravity. If information, mass, and energy are equivalent, then gravity might operate as a process that optimizes the way information is stored in space. Under this model, gravity behaves as a direct consequence of the second law of infodynamics, a law requiring systems to evolve toward states of lower information entropy to maintain efficiency. If you have 100 scattered files on your computer, they eat up memory and processing power. Compressing them into a single zip file saves space and reduces computational load. Applied to matter, when particles cluster together, the system achieves a state of data optimization. This 4-panel diagram shows how mathematical models track the information entropy of physical systems. As the isolated matter particles in panel B merge toward the center in panels C and D, the overall information entropy of the discrete grid drops. This graphic compares this process on a cosmic scale. A vast cloud of scattered dust requires massive computational power to track every speck. When that dust condenses into a single, dense planet, the complexity of information required to track the system is significantly reduced. Viewed through this lens, planetary formation and the force of gravity are expressions of a massive universal data compression event. How does abstract, invisible data translate into the physical stuff we can actually touch? The answer lies in phase coherence. Raw vibration is just chaotic noise, but when independent phases align, they lock together into stable structures. Randomly moving crowds generate visual noise. If they synchronize their movements, a massive stadium wave is born. Coordinated phase creates a new structure. This 3D surface plot visualizes what happens when that stadium wave concept occurs in physics. Physical matter is a highly synchronized wave within the aether substrate. The mathematical models describe this stable, localized pattern as a reality knot. The hard, solid objects we interact with every day are stable, coherent patterns of information, vibrating in perfect unison. When we assemble these pieces, we see a universe that suggests a deeper architecture. The physical objects we touch appear as the downstream effect of a more fundamental informational state. The physical reality we touch, smell, and feel operates remarkably like the 3D rendered output of a complex video game. Our foundational reality is essentially the underlying informational source code that organizes, optimizes, and dictates that 3D render. Modern research is even applying this lens to biology. Scientists are exploring whether structures like DNA are interacting geometrically with this deeper informational field, acting as antennas for data, rather than isolated chemical machines. Quizás la realidad es más extraña y mucho más profunda de lo que imaginamos.